Okay, this is the third video for the first part of lesson 1.1. Looking just very briefly at set notation and interval notation. Please don't get hung up on the set notation. There's one homework question on it, and we just really want you to be able to read it. Occasionally you'll come across it, but nearly everything we do in calculus is in Precalculus is in interval notation. I just want you to be able to read set notation if you actually see it. So we have the set of real numbers, and it's broken down into other types of sets of numbers. It's not a huge deal. Don't expect you to remember all of these at all. Do expect you to know that this fancy R like this means the set of all real numbers. So in set builder notation, as I said, don't worry about this. I just want you to be able to read it. You can tell you have a set because you have these curly braces at the sides. And this is obviously a set with X's in it. Now, this symbol here is probably new to you. What it means is such that. So what this is saying is we have the set of X's such that, then we have this condition here, a comma, and another condition here. This condition here you should be quite familiar with. X lies between A and B, X is greater than A, and X is less than or equal to B. This strange symbol here is just telling us that X is an element of the set of all real numbers. I hope you know the R already. The others, you don't need to know them, but it won't do you any harm to actually know them. I don't know if they'd ever be on an SAT or an ACT test. This big fancy R is the set of all real numbers. Z is the set of integers. That's any whole number from negative infinity to positive infinity. Numbers like negative 54, positive 2, that sort of stuff. Q is the set of rational numbers, and rational numbers are any number that could be written as a ratio in a fraction form, like 1/4 or 2/3. 0.25 is a rational number because it could be written as 1 divided by 4. 0.5 could be written as 1/2. Something that is not a rational number, something that's irrational, would be pi, because pi goes on and on forever. Another thing that's irrational would be something like the square root of 2. Goes on and on forever. That would be irrational, not rational. So have a look at this and see if you can work out what this means. Here are our conditions. We've got two conditions in the list. This is a set of all W's such that W is greater than or equal to A, and W is an element of the set of integers. That's all it is. If you want to try homework problem number 4 now, and on the homework, most of the answers we really want them in interval notation, but number 4 just happens to be easier to write in set builder notation. If you can't do it, it's not a big deal. Just try it. Okay, I'm actually going to just skip past this slide because you don't need to be able to write stuff in set builder notation yourself. So let's move on to interval notation. This you should have used before, but let's make sure you know your vocabulary. There's two types of intervals. Bounded intervals, which have got numbers at each end. There's a boundary value. So this is X is between maybe A is 1 and B is 27, I don't know. Something that's unbounded means the interval either at both ends or one end or the other is going to go to, it's unbounded, it goes to infinity and beyond. Okay, so one end of these, at least one end of these is going to be infinity. So for the boundary values, in this section, your boundary values can be included or excluded. You'll know by these are included, excluded are these. What they'll look like, if you put them on a number line, this will be a closed circle dot. If it's included, and you use a square brace when you're writing it in interval notation, a square bracket. If it's excluded, if you're seeing just the less than or greater than symbol, if you're drawing it on a number line, you'd use an open circle on the graph. And when you're writing in interval notation, you just use a normal parentheses. So have a go at writing these 3 on your own if you want to. Oh, no. Before you do that, let's fill in this table. Pause the video, fill in the table, come back. Okay, so now I'm going to go over example number 1 with you. What I really want you to do, even though you might not feel you need to, is I want you to put them on a number line. I want you to draw the number line, because we're often going to use this when we get on to much more complicated problems called, when we get on to analysing what's happening in certain intervals. You really want to have a number line. So we've only got two numbers we need to put on the number line, -2 and 12, and obviously put them in numerical order with the smaller number on the left and the larger one on the right. So here's our number line. You don't have to count off, there'll be 14 spaces. We don't need that. We just want to have the two numbers we want. These are both less than or equal, so they're both they're both included. And where the x lies it's in between those two values. X is to the right of -2 because x is greater than or equal to -2, and x is to the left of the 12 because it's less than or equal to the 12. So now we can convert this highlighted zone interval on the number line into interval notation just by saying now interval begins at -2 and finishes at 12. We need two numbers with a comma in between them, and then these are both included, so we put braces around them. So try number 2 and number 3 now. Pause your video. Here's number 2. It goes from -4 and x's are greater than -4, excluded, open circle, excluded, and it's any number that's greater than that. So this one's unbounded. It's going to go all the way to infinity, and infinity is always excluded. You can never reach infinity and say, hey, I'm here, and you can stop. So it's never got a hard stop. It's never included. It's always excluded. Okay, on number 3, x is less than 3, x is greater than or equal to 54. So put the numbers 3 and 54 on a number line. Obviously, you've got to put the 3 on the left and the 54 on the right, because it must be in numerical order with the smallest one on the left. Then put your dots. This one's open circle. This one's closed circle. Then looking at this one, we want the x's to less than 3, so we want to highlight the area to the left of it. So that's going to give me one interval here, going from -infinity to 3. And this inequality here is telling me I want x's that are greater than or equal to 54. So greater than means to the right of. So I've got another interval here. So in interval notation, that's going to look like this. Make sure that this is very clearly a square brace, and this one's just a regular parentheses. The symbol in between, the union, it looks a little bit like an uppercase U, but without a stick at the side here. It's actually optional. We call it the union in set notation. If you move into logic on computers, this is actually the same thing as the OR symbol. So, you're ready for your homework now?